Want to see the standard FastMCP middleware setup that handles authentication, performance tracking, and logging in just 3 lines of code? You'll learn how to chain the essential middleware components: Authentication middleware for token validation, Performance middleware for execution timing, and Logging middleware for operation tracking, by simply adding them to your server in the correct order. The pattern demonstrates how each middleware layer wraps the next, creating a clean pipeline where requests flow through authentication checks, get timed during execution, and generate complete logs automatically.
MCP equals FastMCP, my server. MCP, add middleware authentication middleware, secret token. MCP, add middleware performance middleware. MCP, add middleware logging middleware.
This demonstrates FastMCP's middleware chain pattern, where components process requests in registration order to handle cross-cutting concerns. The example shows 3 middleware classes added sequentially: Authentication middleware for token validation, Performance middleware for execution timing, and Logging middleware for request tracking. Each implements the standard middleware interface with a single responsibility while maintaining separation from core business logic. The pattern works through explicit delegation, where each middleware receives the request context, performs its specific function, then calls await call next to pass control to the next layer. This creates a unidirectional flow where middleware can inspect and modify requests both before and after calling subsequent handlers. The simple interface pattern means all middleware follows the same structure, making the pipeline both predictable and extensible. This approach provides a clean way to add operational concerns like authentication and monitoring without modifying your core tools. The example shows a basic configuration where middleware executes in registration order, with authentication running first to validate requests early. In production, you would typically add error handling middleware first and use environment variables for configuration. But this minimal example clearly demonstrates the fundamental pattern of sequential middleware processing. Let's break it down line by line.
MCP equals FastMCP, my server.
Creates a FastMCP server instance named myServer as the foundation for the middleware pipeline. This follows the chain of responsibility pattern where middleware executes in registration order first authentication with a hard-coded token, then performance timing, and finally request logging. The example demonstrates the minimal viable middleware stack where each component implements the same interface pattern, processing requests before delegation and responses after, using the standard await call next flow.
MCP, add middleware authentication middleware, secret token.
Adds require auth middleware with a hard-coded token, implementing basic authentication that verifies each incoming request before processing. This minimal example demonstrates the middleware chain pattern where components execute in registration order, with each calling await call next to delegate to the next middleware or final handler. The sequence shows the standard processing flow: authentication first, followed by performance timing, then request logging, each handling a distinct cross-cutting concern through the same interface pattern. In production, you typically configure the token via environment variables and add error handling middleware before authentication.
MCP, add middleware performance middleware.
This registers performance middleware in FastMCP's middleware pipeline, using the standard chain of responsibility pattern where components execute in registration order. Each middleware wraps the request handling process, can inspect or modify both requests and responses, and delegates to the next middleware via await call next. The example shows a minimal setup with 3 components: authentication with a hard-coded token, performance timing, and request logging. In production, you typically register error handling first, then authentication using environment variables, followed by metrics and logging.
MCP, add middleware, logging middleware.
This registers logging middleware as the third component in a middleware chain, following FastMCP's sequential execution pattern, where middleware processes requests in registration order. The example shows a minimal setup with Authentication middleware for token validation, Performance middleware for timing metrics, and finally logging, each implementing the same interface pattern demonstrated in FastMCP's custom middleware documentation. In production, you'd typically add error handling middleware first, but this example focuses on the core pattern. Each middleware wraps the next via await call next, creating a pipeline where components like authentication and timing execute before logging captures the complete request lifecycle. Middleware registration pattern. FastMCP's middleware system follows a simple chain of responsibility where each component processes requests in registration order, with require-auth middleware validating credentials, performance middleware measuring execution time, and logging middleware recording activity. The example uses a hard-coded secret token for demonstration, while production systems would externalize this via environment variables. Middleware components share a consistent interface pattern, where each implements request processing logic before delegating to the next via await call next.
The chain that never breaks is made of replaceable links.